to use phpMyAdmin, the database administration tool. First thing to note, I'm working at home, which means I need to use the AnyConnect to VPN into campus. When you do this, and then enter my password, my dog's, no, what the hell, that's not right. My dog's name is Fido, there we go. Username and password, this should connect. Look at that. Bam. Okay, I'm now VPN'd into Knox. This was the Cisco Connect Anywhere. Did my little Cisco thing. Probably looks fairly similar on Windows. Now we go back here. Database administration tools. Okay. So the first thing to note, the reason that I had to connect the VPN, the database and the database administration tool, phpMyAdmin, they're running on Euclid. Euclid is not visible from off campus, it's only visible from on campus. And when you log in, you're going to log in with your MySQL username and password, which is not the same as your email username and password. So let's start with that. I'm going to click that. Check it out. I need to log in. What you're going to do is figure out your database name. If you're Alpha Team, your username is Alpha, your password's Alpha. Zulu Team is Zulu, Zulu, whatever. I'm going to log in as root, which you won't have this password, also my dog's name. I'm just kidding, none of the passwords are my dog's name. So right now you can see the only database that's been created here is for Fall 14 is Zulu. I'll create the other ones before lab tomorrow. We got the Hollywood database. What I'm going to do is recreate this database, call it Hollywood 2, just to show you the process of how to use the administration tool. And we had a couple of other databases in there, a test database, web work, I'm not really sure, math uses that for something. This is basically all the MySQL permissions are stored in this database. It's sort of bizarre. MySQL stores all of its stuff in MySQL tables, rather interesting. Anyway, I'm going to go up here to localhost. When you log in, you won't have permission to do this because you'll just have permission to see your one database plus the Hollywood database. I'm logged in as root, which means I can see everything. I'm going to go here to databases. I'm actually going to create a new database. I'm going to call it Hollywood 2. Collation, this is the character encoding. I'm going to pick UTF-8 General CI. That's basically, UTF-8 is essentially 8-bit ASCII. I'm going to create that. This lets it know what the default character encoding is. When you're transmitting information back and forth to the database, you have to know that information. So Hollywood 2 has been created. Bam! Check it out. Now you'll note, no tables found in the database. Hollywood 2 has no tables. So I'm going to start by making my actors table. And so I need to figure out, well, how many columns do I want to have? Now you don't have to have the columns exactly right, because you can always add columns and remove columns. But to start with, you know, let's see what we need to have. We need the actor ID, that's 1. We need the actor name, that's 2. Maybe we need number of Us Weekly appearances, that's 3. I don't know, actor's age maybe, that's 4. And, well, let's go with that. Yeah, let's go with those things. That's 4. Maybe we'll do first name and last name. Nah, we'll go just one thing for name. Here we go. Go. Bam. So we're now doing the part where we create things. Apparently, these days, it throws this up in a panel. If you do more than 4 things, it might not put it in a panel. I don't know. So the first thing we want is the actor ID. I'm going to call that ID. The type, I've got these choices here for the numeric types. Remember, TinyInt, that's 1 bit. So that's basically 256 values. This is 2 bits, so that's 2 to the 16th. It's about 65,000. This is 2 to the 24th, which is like 2 to the 20th is about 1 million, so it's about 16 million. And then this is, of course, 4 billion. And then this is 2 to the 64, which is enormous. How many actors is my database going to have? I think medium int probably covers it. That's about the most we're going to have. Once again, we're going to leave the length or values empty. This is the number of digits wide the number needs to be for printing purposes, which is more or less irrelevant for anything these days, so I'm just going to leave that blank. The default value, I'm going to leave it as none, because this is the primary key. Actually, can't set it to like null or something like that. Your primary key can't be null. Collation, once again, if these are textual fields, you have to set the character encoding. It's not a textual field, so I don't have to. Attributes, this is where you can set something signed or unsigned. Remember, like an 8-bit signed value goes from about negative, well, in fact, exactly from negative 128 up to positive 127, with including 0. Whereas an unsigned value goes from 0 to 255. I'm going to make this unsigned because these can never be negative, right? It's the primary key. It's not going to be negative. This just says, is the value allowed to be null or not? I'm going to say no. This is, do we want to set an index? There's 4 types of index. We're going to set this to primary because it's going to be our primary key. The other types of index, unique means you're going to have some value, but it needs to be a unique value, meaning that only one row of the table can have each possible value that you've plugged in. This is very useful. Well, we'll see where this is useful in a second. You can also set something as an index. You would use this for foreign keys. Full text, this is if you're going to have larger text fields where you can store like megabytes or gigabytes of text that you want to make searchable. This is like a special optimized thing. So anyway, I'm going to make this primary. This AI here, not Allen Iverson, this is auto increment. This means when you add a new row, the first one is 1, the second row is 2, the third row is 3, and so on. It just adds a new value. Very useful for auto increment. Comments is if you want to leave comments. So I don't really care. I don't want comments. I've got the actor's name. That's going to be a varchar, which is basically a string. Now you do need to give a length. How big do I want this to be? I don't know, up to 255. Seems like a reasonable amount. The default value for this, nothing going there. The collation, I'm going to set this again, UTF-8 general CI. Attributes, none of these really make any sense for text values. Can't be null. Do we want to index it? Not really. We could, if we're going to do a lot of, we can always index something. Indexing basically, well, I'll explain this when I talk about optimizations, which probably won't happen until CS320. For now, just know that you can add an index to any column in a database, and what that does is it keeps around a data structure to make it search faster. The problem is there is a cost in terms of overhead of updating all of those extra indexes, so you want to use just the right amount of indexes but not more. Do we need any other information there? No. So that's ID, that's name. What else do we decide we wanted to have? Num us weekly appearances. Actors can have a lot of those. I'll leave that as an int. I could see that Tom Cruise might have 1 billion or so us weekly appearances. And once again, this can be unsigned. What the heck were we going to make this other one? Oh yeah, age. Now for age, we can probably use a tiny int, and we can make it unsigned, right? Because that gives you from 0 to 255. I don't think any actors are going to live past age 255 and still be alive. Although, you know, who knows? So that's what we're going to do. For down here, the storage engine, InnoDB is fine. You can use MyIsm as well. These are actually implementations of whatever APIs MySQL has. InnoDB is the one that everyone's using these days, so I just leave it with that. This other stuff, you know, you can leave comments about the table if you want. I never bother with that. I don't actually know what this does. Well, I'm not going to read it, the documentation. I've never used it before, so I'm not going to worry about it. And again, the collation for this, I'm going to make UTF-8 general. And this is a really bizarre thing about the way phpMyAdmin works. Add one column. If you click go, this will try to add a new column. What you actually want to click is save. That'll create this table. Bam! Look at that. We get the actors table. Now, to go look at this, you'll notice here we've got the actors table. We can browse things in the table. We can look at the structure of the table. We can search for something in the table. We can insert something. Empty the table means delete all the rows in the table. Drop is not only delete all the rows in the table, but blow up the table itself. So if you try to browse this, we'll get back, well, we don't get anything back because there's nothing in the table. If we click structure, this is where we get all of our configuration information of the thing we just created, we can see that this is auto increment. The primary keys are going to be underlined. Down here it's listing what our indexes are, and we can use this to create extra indexes. Occasionally you'll screw up when creating a table and forget to define a primary key. You'll start getting warning messages. You can come down here and add an index, and you can actually index multiple rows, which we will see in a moment. And then we've got row statistics and usage information once you have some data in there. So let's go ahead and create another table. I guess I have a shortcut button here. We'll create it. Oh, wow. Well, isn't that special? We didn't get to say what we wanted in the table, so it assumed that we only wanted 2 columns. This is the movies table. I'm going to call it movies. It's going to have an ID. How many movies do we need to have in our system? Probably medium int is fine. That gives us 16 million movies. If we make it unsigned, I think that should be reasonable. I don't know. It seems reasonable to me. And that is going to be our primary key, and it's going to be auto increment. We also need the title of the movie. That's going to be varchar. I'll let it go up to 255 characters. I think might be the max of a varchar. I'm not sure. We of course want our collation, UTF-8 general. Oops. Hey, what the hell? There we go. Good. And attributes, do we want it to be null? I don't think we want any of that stuff. Ugh, wow, I'm actually yawning. That's probably not the best time to start this. I actually want another column, so I'm going to use this button, and then bam, you see it kept my information but gave me a new column. I want to know the year it was released. I'll make these small int. Well, no, I wonder if there's an option for year. There is an option for year. I wonder how well this works. So one of the bizarre things in MySQL is that a lot of these values are actually like slightly interchangeable. I don't know. I'm nervous. I'm going to stick with a small int, and I'm going to make it unsigned. That all seems reasonable. Yeah, sounds fantastic. Okay. So we got the ID, the title, the year. I don't know. Let's just go with that. Okay. Oh my God, Presto's walking on me. Oh, Presto. Sorry, the cat is all over. I'm not going to re-record this. This is just a prelab. Okay, let's go ahead and we'll save this. Let's see what happens. There we go. Okay, so now we have actors in movies. Now we need one more table for actors in movies. I'm going to show you some fancy stuff we can do with this. So this actually, I don't want to use this interface here. I want to go back to here, and then I want to create new table. I'm going to call it actors _in _movies, and I'm going to give it. Watch this. I'm actually going to give it 4 columns. And I'll show you why in a moment. So let's do this. Bam. Okay, so I'm going to have an ID, actors in movies ID. I guess I'll make this int, because if we're allowing the possibility of like 16 million actors and 16 million movies, we might need a whole bunch of actors to be in movies. That's not. We'll go ahead and make that unsigned. And we'll make it, that's the primary key, and we'll, oh my God, Presto, it's walking on my chest. We'll make it auto increment. Okay, great. Now we're going to have the movie actor ID. Watch this, actor _ID. I guess we'll leave that way. And maybe we'll have movie ID as well. Sorry, I can't get I just realized it's the cat's snack time, and he just will not leave me alone. Because it's like almost 10 o'clock. I may have to go feed him. Let's see how this works. So we're going to make these unsigned as well. And I'm going to leave the index off, and I'm going to show you a trick we can do with the index in a moment. And then actually I'm going to have the name of the role that the actor played. We'll make that a varchar, I don't know, 100 characters, say. And the collation on that, we'll do UTF-8 general, like we did before. And down here, the collation for the whole table will do the same thing. If you leave these off, you can always go back in and change them later. And, okay, now watch this. We're going to save this. This will get created. And so if we go look at this actors in movie table, I should have called it actors in movies. Well, let's actually see how to fix that. And of course, while we're doing it, I'm actually going to walk into the other room and feed the cat here so that he stops bothering me. Oh my god, he's so happy right now he's going to be eating. There they both are. Okay, so actors in movies, what we actually can do with this, we're going to create a special kind of index because it turns out that an actor can only be in a movie once. Let's assume that that's the case. You know, we're not going to worry about, like, Peter Sellers being 3 different roles in one movie, Dr. Strangelove. We're also not going to consider the case of, like, Eddie Murphy playing every role in, like, every movie he's done since Beverly Hills Cop 3 or something like that. We're just going to ignore those slight inconveniences. So watch this. I'm going to say create an index on 2 columns. Because remember, we've got this ID. That's the primary key for the fact that a particular actor was in a particular movie playing a particular role. But the actor can only be in the movie once to play that role. So what we're going to do down here, we're going to create an index on 2 columns. And we're going to set it as a unique index. I never name the indexes. Just sort of leave that off. And we're going to say, whoops, actor ID, movie ID. Now, when you're creating these indexes, size here lets you create the index only on part of things. That's like an efficiency issue. If you have an index on something that's like a varchar, you can only index, like it could be a 200 character long varchar, you might only index the first 100 characters. So that means if you can differentiate between the characters, like within the first 100 characters, it'll be more efficient or something along those lines. My advice would be not to mess with sizes of things that are being indexed until you're very sure you know what you're doing. So you notice there's the 4 different types of indexes. Again, we can't make a new primary key because we've chosen to have the separate primary key. We don't want just a regular index. What we actually want is we're going to make this a unique key on these 2 columns, and I'll go ahead and click Save. Now watch this. When we go down here, we have 2 different indexes. We have our primary key index on ID. That we knew we had. We've got this unique index on actor ID, movie ID. What this means is that actor 1 can only be in movie 1 once. If you try to put in another row where actor 1, movie 1, and like some different role, it'll go ahead and the database will actually fail. It'll crash. It'll barf on that. It won't actually let it work. Now, this doesn't necessarily make it better for searching. This just means that it's basically a constraint that the database has now set so that if you try to put stuff in there that it's not going to allow, the database will actually fail. It's a consistency constraint so that the data has to remain consistent. Because remember, databases, you've got ACID, atomic, consistent, isolation, and durable. This goes under the consistent part of it. You're not allowed to get the database into an inconsistent state. This is a check you can put in there to kind of prevent that. Now, these are both foreign keys. We've put this unique index on it. I'm going to also create, watch this, a regular index on movie ID, save, and I'm going to create another index, let's see if this works, on the combination of actor ID and movie ID. And I'm going to call this just a regular index. Let's see if that works. That totally works. So now I've got a whole bunch of indexes going on here, and it looks like it looks like these might be a little bit unnecessary. So it looks like this unique index is actually going to be the same as this index here. So I'm going to go ahead and get rid of this one. So this unique index has the advantage of not only being an index, which means it's going to make the performance better, but it's an index for actor ID and movie ID. So first, it'll check the actor IDs, then the movie ID. We've also got this index here just by movie ID. This is because this table might need to be searched either way. You might say, well, I know the actor ID, show me all the movie IDs that match it. Or you could say, well, I know the movie ID, show me all the actor IDs that match it. So you could be searching either for certain actor IDs or certain movie IDs. This will let us do either way, and if you're searching for actor IDs and then movie IDs, this index basically covers both. And even though this is set to be a unique index, that's actually okay. It's still an index. We actually didn't need that second index. Now, one other thing we forgot to do, and I sort of forgot that intentionally, plus the cats are walking on me. We come back here to movies. If you remember, we've got the ID, the title, the year. We actually don't have director information. So why don't we go ahead and make a directors table. I'm going to create a table here. I'm going to call this ID for the director ID. How many directors are there? I don't know. Let's go medium int. Wait, what did I miss? No, that looks good. And I don't know, director will also do, whoops, not name, comma, yeah, we'll do name, varchar 255, that looks great. Attributes, primary, auto increment. Oh, right, this should be auto increment. This should be, I don't know, UTF-8 general CI. Let's go with that. Yeah, that looks beautiful. Okay, good. Missing a value in form. What value? Did it let me know what? Oh, yeah, I didn't name it. Ha! What do you know? Turns out you have to name your tables. They can't be empty. Bam, we've got directors. Now we need to have a way for movies to have exactly one director. So we go here. We want to add a column. Add one column at end of table. You can also say at the beginning of table or after a certain ID. I want it at the end of the table, so I'll say go. And I want to now say director ID. These are medium int, so we'll go with that. These are unsigned, we'll go with that. Now these are not, it's not a primary key, so I can't make it primary, but I can index it to signify that it's a foreign key and I'd like it to be searchable. Don't need to make an auto increment or anything along those lines. I think that should work. Bam! There we go. So now we're ready to go. When we look down here at our list of indexes, we've got our primary key, and then we've got director ID. This is essentially a foreign key. So some things to note. The type of these indexes is listed as B-tree. That basically means a binary tree. Essentially what this means is each row, the rows of the table are basically a big linked list. The binary trees just mean you have essentially a binary tree that just contains the values of certain fields, or it sort of like it's a binary tree that references all of the rows, which are essentially a linked list, but using some binary tree structure built up around it to make it more easy to search. So that's basically everything. I guess the only other thing we need to see is how you would insert stuff into this table. That's easy enough. I go up here to insert, and then it's going to give me this nice, lovely interface. Now remember, this is auto increment, so I don't specifically put in a value. I just put in something here, Top Gun. I think it was 1985. I don't know the director yet. I'll have to put that in later. So let's throw that in there and see what happens. Oh, hey, look at that. We can't leave the director ID empty. It's flipping out about that. It's trying to leave this empty. We did not allow that as a possibility, so we're getting a failure. So it looks like we need to put a director in here first. Now, I happen to know that I think it's Tony Scott, who recently passed away, Ridley Scott's brother. And then, of course, since one of the movies will be Avengers, we got to put those two in. So let's put those in. Cool. So we got those in there. And then one cool thing about phpMyAdmin, you go ahead and do this. It actually spits out essentially the SQL syntax it used. So insert into Hollywood2.directors. These quotes up here, these are actually backticks, the one that share with the tilde. So it's saying insert into this database dot that table, these two field numbers, values, null, Tony Scott, null, Joss Whedon. Those nulls essentially mean like null. I'm not going to give you a value for the ID, which means that it triggers that auto increment that we have set for that. Now if we go ahead and browse this, we finally have some data in there. Bam! ID 1 is Tony Scott and Joss Whedon. So now if we go back here to movies, We're going to say insert. Wait, what the hell? Top Gun did get inserted. We just got an error message because it doesn't know what to do with the director ID. Well, I happen to know that... Wow, that's weird. Inline edit. Why didn't it do Top Gun? And then that's director ID 1. Let's see if that works. Okay, that totally worked. And we'll insert into this as well. Title The Avengers. I think that came out 2012, and that was a Joss Whedon film. Let's see if that works. Cool. So that looks pretty good. We go back here to browse, and there we go. And so these are now foreign keys that point to particular rows of directors. One bizarre thing that switches in every different version of PHP, if you click on the name versus if you click on this little icon, in this version if you click on, well, that's weird, the icon doesn't do anything. There we go. If you click on the icon, you actually get the structure view. If you click on the name, you get the list of everything in the row. You get basically the browse view. Bizarrely, those two bits of functionality switch places like every other version of phpMyAdmin, which is very confusing, but for whatever reason they've decided to do it that way. Let me check my notes here and see if I've actually covered everything. That looks good. Add a new table, new column, changing a column, adding an index. We did that. We did that. Changing a column, I guess we haven't really looked at. If I want to sort of change a value that's in there, I can edit or inline edit through this tool to actually change the stuff that's in there. If I want to change the structure of a column, that's a little bit different. Like suppose this title here, I don't want it to be 255. I actually only want titles to go up to 200 for some reason. I can go into the structure view. I can click change. It's going to come down here. I'm going to be like, yeah, let's go down to 200 for this. Now, since none of my movies have anywhere near 200 characters in length, this won't, in practice, make a difference. But if you did have things that were longer, I'd have to, like, truncate them or something. And so if we look at this, we can see, you know, no problem. Everything still looks okay. Cool. I think we're going to stop here. Thanks for listening.